In this video, we will learn about the normalization. First of all, what is normalization? Normalization is a process of arranging the data effectively in the database to reduce the redundancy. We do that tables decomposition. So what is the decomposition? Dividing a table into further tables. So what are the types of the normalization? There are the four major types of the normalization. The first one is 1NF, 2NF, 3NF and BCNF. These are very important in perspective of GATE level. You can easily score 2 to 3 marks easily in every year. First, let us take that what is 1NF. 1NF is a very simple. It just accepts only the atomic values. It does not allow multi-valued attributes. What is a multi-valued attributes? Here you can say that for a single row and a single column you have two tuples. Sorry, you have two values. So you can see that wait. Here if you take that you have two values for a single instance. So these type of values are not allowed because it is very difficult to extract the data. For example, if you want the mobile number of the PG, then what you will get, you have two options. So the redundancy will be more. So how can you reduce that? Yes, it is very simple. Make a copy of it. For example, you have PJ two numbers, you can make separate as PJ one number, PJ one. Similarly, you have RAM two numbers, so make them as separate in a table. Is it as simple as that? So okay, 1NF is done. Let's see about the 2NF. So before going to the 2NF, we need to learn about the prime attributes and non-prime attributes. So let us take an example. With that example, we can able to find prime attributes and non-prime attributes. Later we can easily find that it is whether it is a 2NF or not. Let's do that. Before here already candidate keys are given, so no need to worry about that. So you have given the candidate keys. So what are the prime attributes, non-prime attributes? Prime attributes means the attributes which are a part of a candidate key. So those are nothing but a prime attributes. Here you have A, so include A, and there is a B in the candidate key, so include B, and there is a C in the candidate key, so include C. So these are nothing but a candidate keys, prime attributes. Then what are the non-prime attributes? The attributes which are not there in the prime attributes and which are there in the table, then those are nothing but a non-prime attributes. So what are that? D and E. This is as simple as that. Okay, now we will discuss about what is the condition for 2NF. The condition for 2NF is the part of candidate key should not derive non-key attribute, or you can say that non-prime attribute. This is as simple as that. Now we will take an example and we go and move into the further to get a clear idea on the 2NF. For example, if you have a table like this A, B, C, D, E, F, and you are given the functional dependencies and you need to convert into 2NF. First of all, we need to check the conditions for the 2NF. First of all, it need to be 1NF. Usually given the functional dependencies, then it is always in the 1NF. Okay, it is 1NF. Then what is 2NF? The part of primary or part of the candidate key should not derive the non-key attribute. Okay, first of all we need to find the candidate keys. So now we can find that attributes. Yeah, so what are the present in the right side? You have C, D, E, F. So mark those all, C, D, E, F. So what are the remaining? A, B. So let us try to find the A, B plus. And if you want the candidate key, how to find the candidate keys clearly, I have made a video. You can check it in the below description. Let us find that AB plus. You have A and B And now we will check that what are the other attributes which are derived by A and B. Here you have C because of AB, so include that is in the table. Wait a minute. So include C, and here you have, because of the C you are deriving the D, so make them as D, and you have B in that, so because of E you are getting E and F, so mark them as E and F. So with this you are able to find that all the attributes. So AB is nothing but now candidate key, so there is only one candidate key present in this table, so mark it as AB. Set. Now let us find the prime attributes. Prime attributes is as simple as that what are the attributes which are present in the candidate keys. So those are nothing but A and B. So A and B are nothing but prime attributes. What are the non-prime attributes which are not there in the primary attributes? So those are nothing but non-prime attributes, so include that all. So C, you have D, and you have E, and you have F. That's it. Okay, now whether it is in the 2NF or not, now we will check. We have that AB is the candidate key, so part of it. Here this is not the part, this is a full, so this is not a proper subset, so leave it. So the AB, so AB is not a proper subset, so leave it. Let's see, C is not a part of the AB, so leave it here. Yeah, B is a part of the AB, so here we got the problem and we need to solve that. Now let us try to find that problem. So we have occurred a problem because of B gives rise to E. So what we need to do, so first of all find B plus. B plus equals to, you will get B, and because of B you are here you are deriving E, because of B you are deriving F, so mark all those, you are getting the E and F. So with the E and F you are getting the nothing, so these are the attributes which are derived by the B, so B, E, F. So you need to divide in the table in such a way that we'll show it in a clearly. Initially it will be take some time, but after that it will take in a bit a matter of time. So B plus you will get the B, E and F. You exclude this, and what are the remaining elements are there, so E and F. So separate that and make a copy of this into the other table, that is B. You have the B, so this B is included in the other table also. So now here you will get B. So then now two different tables are ABCD and EFB. So we can make it into a simple, or you can derive you can click a new text box, that's fine. So ABCD goes to the one table, and BEF goes into the another table. Okay, that's fine. Next here have part of, now the next one is B gives rise to F. So the it is a part of a candidate key. Okay, then it is deriving the non-key attribute or non-prime attribute. So here also you have the problem, but this problem is already solved, because here also you find the B plus, you will get the BEF. So already BEF is separated, so here no problem. So all the functional dependencies are done. So now what we need to do, we need to arrange them in this table, and we need to check that whether it is in the 2NF or not. Now let's do that. So here you include that AB gives rise to C, yeah, that's fine, and you can include that C gives rise to D, yes, it will comes into this table, and B gives rise to E and B gives rise to F comes into this table. So B gives rise to E and B gives rise to F. Now you check that in this you find the candidate key, then you will get that candidate key as candidate. You can let us the CK is the candidate key, and here you will get that candidate key as AB, because with the AB you can derive the C and D. So here the part of, you can check that now part of this is not a part of AB, so leave it. This is also not a part of AB, so leave it. So this is in a 2NF. Now check, we will check in other table, and in this the candidate key is B, because with the help of B you can derive E and F. Therefore it is not a part of B, and it is also not a part of B. It is B but is not a part of B. It is not a proper subset. So in this way we need to convert into the 2NF. It is as simple as that. We take a some quick revision. First of all, you need to find the candidate keys and prime attributes and non-prime attributes, and check for every dependency, functional dependency, whether it is satisfying the conditions or not. The condition is the part of a candidate key should not derive non-key attribute. It is as simple as that. And here you have another example. So now I will go quick forward when compared to the previous one. So first of all, we will find the candidate keys. So what are the candidate keys? You will get is nothing but, you first of all mark it that simple, CFEG. So mark CFEG. So CFEG is marked. So CFEG is marked. So the remaining must be included into the candidate key. So A, B, D. Now we'll check that whether it will form a candidate key or not. So include that A, B and D, and with the help of AB you are getting the C, include C, and with the help of B you are getting the F, so include F, and with the help of A you are getting the E also, and with the help of E you are getting the G. So A, B, C, D, E, F, G. So all attributes you are getting. So the candidate key is nothing but A, B, D. So it is as simple as that. So mark it as A. So there is only one candidate key, and there can be more than one candidate key. So in this example you get only one candidate key, and let's see that. So what are the prime attributes? It is as simple as that. Only there is a one, so include all the attributes A, B, D. Next, what are the non-prime attributes? You will get as C, comma D. D already is there. E, F and G. It is not A, B, D. It is A, comma B, comma D. Now we will check that each one by one, whether it is satisfying the conditions or not. So what is the candidate key? ABD. So AB is a part of ABD, but it is deriving the non-key attribute or key attribute. This is non-key attribute, so the problem occurs. So first of all we need to find the candidate keys. We need to find that so problem is occurred because of AB gives rise to C. So find the AB plus. So AB plus A comma B, A comma B. So with the help of A and B you are getting the C, and with the help of C you are getting nothing. No, with the help of A you are getting the E, and with the help of E you are getting the G, and you are getting anything. With the help of B you are getting the F. So that's it. So here D can't be derived, so because it is not a candidate key. So we need to divide in the table in such a way that A with you remove except AB and make them all, or if you take, even when it's simple, make a copy of it. So first of all we need to erase the previous one so it will be clear for you. Yes, now we will divide the table in such a way that AB, so without AB you have again C, E, G, F. So C, mark it as C, and E, F, G. So place these all in the other table. So we will place it in the other table. Let us consider that table B C, E, F, G, and you are getting because C, E, F, G because of A, B plus. You find this, so include those. And the other table is left over the elements here which is not marked, A, B and D. So A, B and D, that's it. Up to now this is the we have divided into two tables. Let's see we need to divide into more or not. Now B gives rise to F. Is B gives rise to F is making a problem in this, because B is a part of a candidate key which is deriving non-key attribute, so problem occurs. So next you need to find that B plus. So I'll go figure, you are getting a B because of E, B you are getting the F, and that's it, you are getting the B and F. So separate this into the tables as, so mark it as B and F. Okay, you marked it successfully, and separate them. So B and F, B and F. Why B? Who? Wait. Yes, you are getting the B and F, and so B and F make it into the another table. And what are the left? Oh, there is small mistake in this. So B is not to be included because you except B you need to find all those. So you have F. So next one B and F. So B and F you successfully find that. And what are the leftover elements? A, B, C, E and G. That's it. Done. So what are the A, B, D other table? So that's it. Now we will see that we need to divide or not. So here A gives rise to E. Again you need to find, because it is also a candidate key. So find A plus, you will get A and E, and because of E you are getting again G. That's it. So A, E and G. So this is in this table. So again you need to separate that. Except A you have E and G, so mark it as E and G and try to separate those into the other table. Now we'll do that. So E and G into the other table, and E and G is coming because of A, so include A, and you write the other elements as A, B, C, A, B, C. That's it. Next, or you remove the write the other tables B, F and A, B, D. I will check the other one, which is nothing but E gives rise to E. E is another part of a candidate key, so no problem. So now so the final you got is this one, the final set of the tables. This is nothing but A, E, G. First of all we need to make them as separate. First of all, in this you need to include all the functional dependencies in one, at least in one table, so that it will functionally it will be preserved. So here AB gives rise to C, you need to include here AB gives rise to C, and here B gives rise to F, B gives rise to F, and A gives rise to E, so A gives rise to E. Oh sorry, not here, A gives rise to E. Then the last one is E gives rise to F, so E gives rise to G, so include this E gives rise to G. So that's it. So and one thing I need to say that if you have only one attribute, then it is perfectly fine. It will be always in 2NF. You need not to be checked, because it will becomes a candidate. This will becomes a candidate key, and there is only one. There is no other chance to get a part of a candidate key. And so we need to check in this table. So in this table the candidate key is A, so there is no part of it, so this is in the 2NF. So in this way we need to find our 2NF.